privileged here to be up on stage talking about AWS and Lookout for equipment. I'm going to walk through Case's application and how we've deployed this across our sites. So same flow, same concept. The opportunity for us was how do we actually successfully implement and scale predictive maintenance across hundreds of assets, critical assets across our sites, knowing that each asset has a lot of unique operating conditions. And when it comes to scaling our ML models and scaling our capability within a resource constraint state, not having a dedicated team of data scientists or thousands of data engineers able to source the necessary data, how do we actually achieve this at scale? And so we've partnered with the Lookout for Equipment, the AWS team, and we've been able to have great success in actually leveraging the platform, modeling the equipment behavior, and diagnosing failures, diagnosing issues before they become an actual failure. And so our think big, start small, scale fast approach was really centered around developing those asset-centric models to leverage all the data, all the critical data associated with those assets. Our focus was quickly deploying those models on a small subset of key assets across our sites, and with the mindset that we were resource constrained, that there are unique conditions and operating states for these assets, and that we do have thousands of sensors and a very an existing architecture today that when it comes to sourcing that data, gathering those insights, and consuming that. So key points, things that were in our forefront when it came to developing this solution is that when we wanted to have minimal to no ML expertise required for the operations or the engineering team when it came to developing these models. We wanted to have a holistic approach, meaning we wanted to be able to capture all the data around the machines and around the assets that we had today. We wanted the models to be asset-centric. We wanted them to be unique to the asset based on the operating conditions, based on historical operating states for that asset. We wanted this to integrate with the existing workflow that was already in place for the operations and the engineering team. So we didn't want to provide them new tools, new technology outside of the existing processes, the existing technology that they were using today. We wanted these models to be developed in hours, and so speed was of the essence in terms of the sites and the engineers that already have the workflow, already have the process of leveraging platforms like Seek today when it came to building out their analyses around those assets. We wanted the ability to scale this in a way that we could increase our ability to monitor, detect, and understand if there were deviations or potential failures. The other component within this is we wanted accurate and we wanted transparent ML models. We didn't want a black box. We wanted the ability for the operators and the engineers as they built these models to get the feedback, to understand what are the conditions, what are the operating states, what is the model actually telling me, and what's driving our potential failure. And again, the final point here is leveraging our existing architecture. How do we take advantage of what we've already invested when it comes into platforms like Seek, when it comes into AWS and our existing data lake, our existing cloud? How do we leverage the existing connectivity within our OSI, our Pi historian, and get the value that's already been invested? And so how does it work? Let's look under the hood and let's provide you an overview of the partnership that we've had with both the AWS team, the L4E team, and Seek. And so a very simple diagram, a very simple flow here of how the actual information is consumed, fed up to L4E, and then provided a feedback and input back to the actual process engineer. And so users today, operators and engineers can actually build all of these models within the Seek workbench. The individuals can identify their assets, leverage the existing AF or the asset framework structure that we have today, identify those key processes and those key points that they're wanting to model around those assets. And again, the key thing to keep in mind as you look at this, the operators and the engineers and our data scientists are not interacting with L4E. They're in their existing workflow, they're in their existing technology that they're comfortable with and know today. Those process engineers and operators are able to actually build those models within minutes, deploy those models within a click of a button, push that to L4E. Then they get the interaction back in terms of after the model's been trained, after the inference has occurred. They then have the continuous monitoring and the uplift that we've seen from L4E. Seek then displays those inputs and results back to the users, giving them the feedback, giving them the ability to analyze, the ML models that we're getting from L4E. So the key thing to highlight here as we approach this is that ease of use, that ease of flow, leveraging our existing architecture and our existing partnership with Seek. So from a current deployment standpoint, we have this across 5 of our sites, 41 critical assets, and we're targeting to scale to hundreds of our existing critical assets within the next 12 months. The other thing that we've identified as we've gone through this with the L4E team is not only are we able to analyze equipment health, but we're also seeing applications around the process health and identifying deviations from a process standpoint. So now I'm going to walk through a particular use case where we actually have had success within our use of L4E. Within this example, we're looking at a major compressor, and L4E was actually able to detect this failure hours before any of our other monitoring and our existing anomaly detection processes. So L4E correctly identified and alerted to a bearing temperature issue on this major compressor. What this then provided us was the ability to detect and also then monitor this potential failure before it became a bigger issue. What we also saw within L4E as it continued to diagnose and monitor this issue was provide the operations team and the engineering team the feedback on how do we continue to maintain and operate this asset without bringing down our production process, but keep it in a healthy state. And so the uplift that we saw from L4E was that it continued to inference, it continued to monitor this asset and provide the proper feedback and the diagnosis over time of changes around that current operating condition. This then allowed us to develop a short-term mitigation as well as a long-term mitigation to ensure that this asset continued to operate during high-value times for us in current markets. So what are next steps for us from a case team? First off, I'd like to thank the AWS L4E team, so Brent Swindler, Alicia Trent. I'd also like to thank the Seek team, Chris Orr and Chris Herrera. And then also from a case perspective, Michael Robinson and Hunter Lowmaster, who were critical in both the deployment and our success of capturing value within this use case. I think Michelle said it well, it takes a village to create value here within these use cases, and we've seen that partnership from the AWS team as well from the Seek team. So we look to continue that partnership with the Lookout for Equipment team, leverage the learnings and continue to optimize and scale our usage across our critical assets. We also look to continue that partnership with Seek as well as Black & Veatch from a monitoring and diagnostic standpoint. So accelerating our use of these ML models across our critical assets, looking to, again, strategically apply L4E not only on the equipment side, but also on the process condition side, where we continue to see value there, and then increase our exposure across the fleet for our reliability SMEs on how easy and how quick we can deploy these solutions across our high-value assets.